All right, and we are live. I assume everybody had a relaxing, uneventful spring break with no changes in your daily lives.
We wish.
Yeah, so a couple of announcements. First of all, I know this isn't horribly ideal, but we're going to make the best of it. And so a couple of things to pay attention to if you want to have some digital human contact. I'm always happy to create a private Zoom channel just for you if you have like your study group or something like that. Otherwise, what I would encourage you to do is, excuse me, is go into, for channels, there's a channel that is now up called the Digital Happy Hour channel. And if you join that, you should be able to see the link for Bitwise Bar and Grill. I'll even put it into Slack here for 200. So what we've been doing is I've been scheduling kind of daily, I call it happy hour type things in there. But, you know, so we've been watching, I don't know, comedy videos and movies and things like that. So if, look for those invites if you want to come together with a group of people and just chat, vent, whatever. So, you know, it's kind of a digital restaurant, if you will, bring your own beverage of choice and food or whatever. But, you know, just a fun way of kind of keeping normality as best as we can. One thing you'll notice once you're in there, though, is you can create rooms. So, yeah, you can create rooms in there and then go and join that room. So if you want to do like a little breakout sessions and things like that, you can. I might need to turn on some permissions in there to allow everybody to do that. So I'll look into that just to make sure that that's truth in advertising, but it's certainly something that Zoom allows you to do. So I'd encourage you to have your study groups in that central location. But if that isn't working for you for whatever reason, send me a message and I can create you a private Slack channel or a private Zoom channel rather, that you can still meet with your groups to work on homework and that kind of stuff. In many ways, it's actually more convenient because now you can share your screens and everybody can see it more easily than having to shoulder surf over a laptop, something like that. So in any case, that's one thing. A couple of other things, you maybe have seen some announcements on Slack if you've been paying attention to it. Well, having said that, I would try to increase your viewing of Slack, turn more alerts on and things like that, as you know, we're going to be more reliant on digital communication than ever right now. But the university is a part of several different endeavors. Right now we are using our makerspace to 3D print N95 masks for hospitals. So we have several student volunteers who are still in the area who have gotten involved in that. I say volunteers, we're going to pay them. So if any of you are still in the area and are interested in making some extra money you know, for either assembling masks or helping with the printing of them, we have the print farm going 24/7. So I think right now we have 5 students who are helping out with that, as well as our GA Blade, the guy who's down there all the time. So if that's something you're interested in being part of, send me a private message. I'll get you into the group. But that's a cool thing that we're doing with the Milwaukee Public Health, and we're also giving masks to Madison and you know, doing our part, I suppose, and we'll, you know, the hope is that now that the other industries that like serve construction and stuff can start making masks, they'll be able to catch up, and they won't need to use our 3D printed mask, but they'll be able to use a more, let's call it appropriate mask. But, you know, in a pinch, the 3D printed ones that are assembled are better than nothing. So that's one thing that's coming down the pipe. Another thing is we're working with Aurora WDC, Eric from our first Tech Talk. He's involved in a national movement to figure out how to stem the flow of the virus. And there might be some opportunities for students to get involved in that in various capacities. So keep your eyes open for that. We currently have 18 students who are writing some software for that part of things. So upper division students who are writing artificial intelligence software for that. But, you know, there will be other opportunities to be involved at whatever your skill level is, including just, hey, I want to be a cheerleader. So and root you guys on. So it's you know, lots of interesting opportunities here. It's, you know, obviously it's a strange time, but thank God that we have the technology to be able to still have classes. You know, I know this isn't necessarily what everybody signed up for, but, you know, at least our school's not canceled and we're able to keep moving forward. So that's the current state of things. All right, so before I go on with our, continue on with our lecture stuff, does anybody have any questions for me about, I guess, anything related to school stuff?
Yeah, so I had one question concerning the Tech Talk. Like, is that still going to be going on, or is that going to be canceled?
That's a good question. I don't know the answer to that. Was it next week?
Yeah, I think it's sometime in April.
Yeah, so I'll get you an answer. If it goes on, it'll be via Zoom, obviously.
Okay.
But let me confirm up with the speaker. If it doesn't happen, I'll just give everybody 100% for that field instead of removing it. That way, you know, it's points that you were expecting to have part of your grade. So I'd like for it to still happen if we can make it happen.
Right.
But let me confirm with the speaker and make sure that she's okay with it, because who knows what her situation is. She might be sick or something like that.
Yep.
Yeah, so yeah, it looks like it's April 7th is when it is. So I will confirm with her the scoop on that. Let me add that to my list here.
Yep. Sounds good.
All right, anything else? All right, and let's see, I think I can get the chat window open. I have a little bit of a different setup now that I think will allow me to see things as they pop up. There we go. All right, so I have a big monitor above me here, so I put the chat window up there. I can't promise I will notice when something pops up, so let's just continue with the whole, if you have a question, just blurt it out mentality, and we'll go from there. But I should be able to see the chat window is the theory of stuff. And let me do this up there. Okay, so let me go ahead and now share my screen. And let's start doing some stuff. All right, so everybody can see my screen now?
Affirmative.
Okay. And you can still see the code screen if I swipe like that?
Yes.
Got it. Okay, so then let's kind of review where we were at last time. We started to talk about our objects. And we kind of talked about we up to this point we've had some building blocks. I know this is going to review some stuff, but lots happened since we were in our last class. So let's just get back into gear. So up to this point, we've looked at dictionaries, and we've which are just name value pairs, so we can keep track of multiple pieces of information. With names associated with it, like first name is equal to Mike, last name is equal to Littman, so on and so forth. And then we've had this idea of functions, which are reusable chunks of code, and these sometimes can operate on things like dictionaries or other things. But in our world right now, these things have been living separate from each other. So we gave some examples of that down here, where if I wanted to, right now we're just using examples like, let's say I want to represent a fraction, just something very simple, where a fraction has a numerator and a denominator. We can represent a fraction as a dictionary and give it something called a numerator and set that equal to some value, give it something called a denominator, set that equal to some value. And then if I wanted to print that fraction out in some sort of pretty way, for example, I can create a function called print fraction that takes in a fraction dictionary, for example, as a parameter. And then it would go through and kind of give me a pretty looking numerator followed by a slash followed by a denominator for the fraction. But these two things are completely separate from each other, right? So we've decided just haphazardly that, oh, we're going to represent our fractions as dictionaries. And then we said, you know what, I might want to do stuff to those fractionary, or to the fractionaries. That's actually a pretty good name for it. We're going to actually want to do stuff to those dictionary representations of fractions. Is there still homework due on Wednesday? I think the answer is yes, but let me review that. Because I think right now the assignment doesn't have a content to it. So I'll see where we get to the end of this. So the answer is probably going to be yes, but it's going to be an assignment based on what we talked about today. Okay, so we can decide that we're going to represent fractions in this format, and then we decide we might want to do stuff to fractions that are in that format. So we would just write some functions to just live out here in the in the wild. Those two things are not linked to each other than the fact that we have chosen to have them be related to each other. All right. So for instance, I can create a fraction, and then I can say I'm going to go ahead and use my function called print fraction, passing it that fraction dictionary, and this guy will do the magic of working with that. All right. So as you can imagine, if you're going to have lots and lots and lots of abilities you might want to do with fractions, this is going to get pretty messy pretty quick, because you're going to have just this hard-coded idea that, oh, I'm going to represent my fractions as dictionaries, don't screw this up. And then you have all of these functions that you've written that are completely disconnected from that idea, that you have to remember that you need to pass a fraction dictionary to make it work. So one thing we can do is we can pull these things together. We can say we're going to create a class. So this is where we start getting into object-oriented programming. We can create a class where we have the aspect of it that's the dictionary, so a bunch of name value pairs, as well as the functions that are meant to operate on those name value pairs. So this guy is called a class. A class is a collection of 3 different kinds of members. We have fields, we have constructors, and we have functions. So the fields kind of replace our idea of the dictionary, where we have variables associated with values. The constructor is the guy for initially setting up the values for the what are called the instance members of this class. And we'll see that by example. And then the functions live inside of this class as well. And these guys will operate, they don't have to, but they'll generally operate in terms of the fields that the class knows about. All right, so a field, variable that holds information about a particular instance of an object. When I say instance, I'm talking about like if we had 5 fractions, fraction F1, F2, F3, F4, each of those guys would be an instance of a fraction, each one having its own numerator and its own denominator, where F1's numerator would probably be different than F3's numerator, that kind of thing. So they're the same mechanical structure, same logical structure, but the contents inside them are different. All right, now we have this idea, so this is kind of where we left off. We have this idea of a constructor. So this is a special kind of function that initially sets up an instance of an object. And we can say that this can only be called once when we are first creating the instance of the object. And we see this guy, it's got to have a very special name. So it's underscore underscore init underscore underscore, and then it takes in some params. And let's look at this by example. So here's my fraction class. And I've decided, so here's my constructor. This is the guy that's going to build a fraction for me. All right, for right now, just assume that all of our methods, all of our functions will have this little self comma thing before it. Don't worry about that for right now. We're going to give meaning to that here pretty soon, maybe even today, but just assume that the first parameter must always be that for right now. All right, and then here are the building blocks. If you were building a fraction, if somebody says, hey, I need you to build a fraction for me, what pieces of information would you need? Well, you would need to know what the numerator is and what the denominator is. Those are the pieces of information you need for building a fraction. All right, so with that being said, we're going to say, I'm going to take in a numerator, I'm going to take in a denominator. Now, you can name these whatever you want. These are just parameters like any other function. But again, good naming convention, especially in a loosely typed language, should say that, well, you want to give some sort of meaning to these variable names. So what am I expecting it to pass me? I'm expecting you to pass it a numerator and a denominator. We can assume those are numbers. And what am I going to do? I'm going to set this guy's numerator equal to the numerator that was passed in. Let me go ahead and let's just give initial value to that self. So self. In other languages, well, let's just give definition to it first, and then I'll say what it is in some other languages. Self is how an object, let's say how an instance of an object refers to itself from within itself. So kind of like a human saying me, right? So if I'm talking about me or myself, I'm talking about Mike. If one of you is saying me or myself, the exact same word, you're talking about your instance of human, right? So self is how an object refers to itself from within itself. If I'm talking about myself, I say me or my. If you're talking about yourself, you say me or my. And then we all have similar fields, eye color, things like that. Okay, so self is a kind of a special variable that gets created for us that allows us to refer to ourself. In some other languages, let's see, other common equivalents. Commonly, you'll see the word this used for how to refer to itself. So Java, C#, they both use this. Some languages use me. Actually, one language uses me, Visual Basic, that I'm familiar with. I think that's pretty much the common thing. So in terms of what you'll actually see in your modern languages, it'll always be self or this. Let's call that 99% of the time. Those would be the two words that mean the same thing. All right. So in any case here, with my constructor, I'm saying, I want you to give me a numerator and give me a denominator in order for me to work. And what I will do is I will set my numerator equal to the numerator you passed in. And I will set my denominator equal to the denominator you passed in. That's what the self dot thing says. All right, so I think we already had this in the notes, but I'm gonna just put again. Let's just call this truth. All variables boil down to their most local definition. This is related to when we were talking about scope, variable scope, where a variable is accessible. So we're going to say self is often used to bypass this rule by giving the, we're going to just call it full path to where the variable we are referring to lives. And what I mean by that is this. Inside of this special constructor, so this guy looks a lot like a normal method, it just happens to have this very special naming convention. Underscore, underscore, init, underscore, underscore. It's that's how Python tricks itself into letting you create a constructor. I've taken in a numerator and a denominator here. Why did I name them that? I mean, I could have named it num and denom, and that would have maybe been, you know, allowed me to separate the difference between numerator here and num here. But we would call that kind of the lazy approach to it. You should name your variable names something appropriate for what you're expecting. I'm expecting a numerator and a denominator. So when I say numerator here, it will boil down to its most local definition. Its most local definition is numerator right there. Okay, so in the scope, we have a scope associated with this particular function. If I bounce back to one of our pictures, we have like yellow boxes and stuff. Yeah, so we have like this global scope thing, and then each of our functions has its own scope. So if we think about our function here like init, this init function has its own scope where we have a variable called numerator, we have a variable called denominator, and then we have this kind of hack variable called self that makes object-orientedness work in Python. All right, so when I say numerator inside of this function right here, it's going to look in the most local scope first, and it's going to find, oh yes, we have a binding for a variable called numerator. So when you say numerator here, you must mean this guy, the value that was passed in for that guy. Well, that's great. That is what I mean in that situation right there. But what I ultimately want to take, what I want to do is I want to take the numerator that was passed in and I want to set it equal to, or I want to set my global or my instance variable, my field associated with this fraction called numerator equal to that guy. And we can do that by using self to give the full path and saying, I want to set this particular guy's numerator equal to the numerator that was just passed in. I want to set this particular guy's denominator equal to the denominator that was just passed in. That allows us to use appropriate variable names that are meaningful, yet still distinguish between this local variable numerator and the field numerator that belongs to this class. Okay, so the self keyword is very important in object-oriented programming. All right, so the job of a constructor is to initially set up a fraction. So if we do nothing else, and that scrolls fast. So I'm going to go ahead and delete some of these things and just move towards our object-oriented stuff. So here I have called my fraction constructor 2 different times. So when I create a fraction, here's a variable, I'm setting that variable equal to whatever is returned by the fraction constructor. Okay, so this is calling that init method of fraction. The init method of fraction expects me to pass it 2 parameters. Remember, the self thing is like a magic thing. We never actually pass self around. It automatically happens. So this always needs to be a first parameter in all of your instance methods. Just for right now, just let's think about it in terms of methods that are in your class. But you'll never actually pass it when you call it. It just needs to be there. These are the parameters this guy takes. He takes 2 parameters. So we will pass him a numerator and we'll pass him a denominator. Similarly, we'll pass him a numerator and we'll pass him a denominator. So these are both calling the init method, but passing in different parameters for numerator and denominator. And this particular init method will set that guy's numerator to 1 and that guy's denominator to 2. This particular one will set this guy's numerator to 3 and this guy's numerator or denominator to 4. All right, and we're storing those inside of these variables called F1 and F2. All right, now if I print out F1 or I print out F2, we're going to see that what actually gets returned by this init function is a memory address where this fraction lives in the computer's memory. All right, because now we're building something. This kind of goes back to when we talked about how lists and dictionaries are passed by address, and strings and ints are passed by value. So if we make a change to an integer inside of a function, that change does not have side effect. We will not recognize that change outside of the that function. But if we pass a list into a function and we make changes to that list, we will notice those changes external because we're actually passing a pointer, the memory address where that list lives. So inside that function, we are operating on that original list. So this is that example I used about probably spray painting my garage. If you have the address of my house and you run over there and spray paint my garage when I get home, I'm going to be in for a surprise, that type of thing. So in any case, if I print these out, we're going to see some memory addressy looking things. So here's memory addresses. So we have a fraction object that lives at this memory address in the computer. That's just a big hexadecimal number. And we have a fraction object that lives at a different memory address inside of our computer. Okay, so that is the the idea of when we create an instance, F1 and F2, these guys are actually holding memory addresses where that fraction object actually lives. If I were to print out F1's numerator, that's when I'll get the 1, which is the numerator associated with F1. So this says, go to that memory address and give me the numerator associated with that guy. F2.denominator says, go to this memory address and give me the denominator associated with that guy, which should be our 4. All right, that makes sense? So these are kind of the fundamentals of how objects work in terms of their fields. We build an object using the constructor, and usually that's going to mean setting its fields equal to some values. Now, keep in mind, we might also do some other things inside here. So I might, just to give a, maybe I do something like this, self dot float representation is equal to self.numerator divided by self.denominator. So I've only taken in 2 parameters here, but I've gone ahead and decided I'm going to store a third value, which is the numerator and denominator divided by each other, the floating point representation of this fraction. Just to give an example here that you don't always have to take in all the values you might internally set. You just need enough information to get started. You know, maybe an extreme idea of this, if somebody's building a house for you, if you just hand them a wad of cash and tell them where to build the house, they'll build the house. They'll buy all the boards, they'll buy all the nails, they'll do all the stuff, run all the electrical. So, you know, you don't have to give them 4 million things in order to do their job. You just give them the minimum number of pieces of information they need to actually create, in this case, a fraction. It needs a numerator and denominator. I'm going to set those 2 things, but then I'm going to also keep track of a third thing just because. So now down here, if I were to print out F1 dot float representation and F2 dot float representation, we're going to get the floating point representation of 1/2 and 3/4. So there's our 0.5 and our 0.75. All right, so a constructor lets us take in the needed information to create, to construct an instance of an object, and then it will set those fields or set fields that are appropriate for that object equal to whatever values they need to be. All right, so that's what the constructor does. So we have our fields, we have our constructor, and then we have, typically, in object-oriented programming, we call these guys methods. So this is for function. It's a synonym for a function. I don't spell that wrong. All right. Just object-oriented programming typically calls them methods. So I'll use those terms interchangeably, probably. So these work just like traditional functions where they perform whatever task they were designed for. We might say often these tasks operate on the fields of this instance of the object, but that is not a requirement. And what I mean by not a requirement is I can come in here and I can create a method called print hello. That just prints hello. It does nothing with the fields of this fraction. In fact, it doesn't even make sense for fractions to have this ability, but it does. In fact, I might even throw this out here for our methods. We can think of these as the abilities or the behaviors of the object. These are the things that instances of this object can do. So here I've said a fraction can construct itself, it can display itself, it can give you a string representation of the fraction. These are things we wrote before. So here's a method called display that takes in no parameters, and it will just print to the screen the numerator followed by a slash followed by the denominator. Similarly, we have something called get fraction string. Maybe we want our fraction to hand us a string representation of itself rather than print a string representation of itself. In this case, it's going to return, instead of print, it's going to return a string formatted representation of itself. Maybe we're going to use that in another part of the program or something. All right. So both of those make a lot of sense. These guys are operating on the numerator and denominators that belong to that particular fraction. This last one is a perfectly legal method. It's called print hello. It takes no parameters. Well, actually should still take self. Okay, it takes no parameters. And all it does is print out hello. Doesn't use the numerator, doesn't use the denominator, doesn't do any fancy logic. Kind of a complete waste of time. It's like when you go and buy one of the new cell phones or something that has 4 million features and 3.9 million of those features you would never use, but it has them. It doesn't make any sense for it. But in any case, here's a fraction that knows how to print hello for some odd reason. So now if I just say f1 dot print hello, and I say f2 dot print hello, these are methods that belong to an instance of a fraction, and this guy always prints hello. So there's my f1 printing a hello and my f2 printing hello. That's all he knows how to do is print hello. All right. So we would say that that is perfectly legal code that really doesn't make a whole lot of sense, is what it comes down to. All right. This is not a great ability to include inside of fractions. Doesn't really have anything to do with fractions. All right, so those are our components of an object. We have the fields, we have the constructors, and we can have more than one constructor. So for example, I can create a second constructor here, def underscore underscore init underscore underscore self, and let's just have them take that in. And we'll go ahead and say self dot numerator is equal to, I will just say 1. Self dot denominator is equal to 1. Self dot floating point representation is equal to self dot numerator divided by self dot denominator. All right, and then what I'll do here, I'll create, actually, let me leave that stuff there for your, so you have it in your notes. F3 is equal to a fraction. And then I'll go ahead down here and I'll say print F3, and we'll see we get a memory address. And then I'll say print F3 dot numerator, print F3 dot denominator. Oh, interesting, because I gave it a, oh, this is a little bit of a, here. I'll explain why here in a second. Oh, it's only gonna let me. I could write more than one constructor. I must be missing a keyword in here. I'll look that up, but for right now, it makes sense for us to have our fractions working with numerators and denominators. There might be some situations though where we would create, I was trying to create kind of a ghetto fraction where, you know, we didn't give it a numerator or denominator, it just kind of gave us a default value for those guys or made something up. That would make sense in object-oriented programming. So for instance, if we think about this in real life, so I'll remove that from now and I'll get the right syntax for that and we'll add it next time. But a real life example might be if you're gonna hire somebody to construct your house, you might You can just give a contractor a wad of money and let him go out and find the land, buy all the stuff, build the house, all that stuff. Alternatively, you could give him all of the components he needs to build the house. You can give him the land, all the wood, all the supplies, all the everything, plus the money for his labor to put it all together. And that would be another way of constructing that house. So it's possible that the same contractor would operate off of both of those models. He might say, give me a bunch of cash and I'll do all the work, or give me some cash and all the material and I'll do the work with that material. So two different ways of constructing a house through the same contractor. All right, so we have ways of creating more than one constructor if that would make sense for us. And there's just some little keyword I'm missing for an alternate constructor here, I'm sure. All right, but for right now, this solves our problem. We have a constructor for constructing a fraction that takes a numerator and denominator. We have the ability for a fraction to display itself. We have the ability for a fraction to return a string representation of itself. They also know how to print hello for some strange reason. We'll just call that a non-value added feature. Okay, so now we have fractions that can do things. So for right now, I'll go ahead and excuse me. So right now we have our two different fractions. And then we start thinking, what are some things we might want to do with fractions? Well, maybe we want to add fractions together. What does it mean to add fractions together? So if I were to have a fraction 1/2 and I were to have a fraction 1/4, and I want to add those guys together, how does that work? How do I add 1/2 and 1/4 together? Going back to, when did we learn about this? 3rd grade math, maybe? So what's that process?
You would have to get a common denominator.
Okay. So common denominator. How do you get a common denominator?
Multiplication.
Okay. And specifically, I'm multiplying the two denominators together, right? So we're
Yeah.
going to multiply the two denominators together. So in this case, we get 4 times 2, which is 8. So we have 8 as a common denominator now, right? Okay. Then what do we do? So I have a common denominator, which is going to be 8. How do I add 1/2 to 1/4?
You have to convert the numerator so that they work with the denominator.
Okay.
You multiply the denominator with the other numerator.
Yep. So now we need to multiply our numerators by the appropriate value to scale that fraction to its equivalent fraction with the common denominator. So in this case, to get 1/2 to have a denominator of 8, we have to multiply the numerator by 4. So 1 times 4 gives you a 4. So now we have 4/8 instead of 1/2. Similarly, we have 1 times 2, which gives us a 2. So now we have a 2/8 instead of a 1/4. Okay. What's next? So now I have my numerator and my denominator scaled so that both fractions have the same, have a shared denominator. Now I can just add directly. Add the numerators. And keep the common denominator. So we'll say 4 plus 2 is equal to 6. So we have a 6/8 as our answer, right? So that's how we add a fraction. Now, typically, after we have a fraction, we want to show a fraction in reduced form, right? So for instance, if I have 6/8 and I want to reduce this to its lowest form, how do we do that? What's our goal to turn 6/8 into its reduced form? What are we searching for? So we know the reduced form of this guy is going to be 3/4, right? A human being can look at that and say, oh, well, 6/8, that's the same as 3/4. And we can't break down 3/4 anymore. So we're going to say that's the reduced version of fraction. So we're going to say, how do we get this? Because we need to come up with an algorithm for taking a fraction like 6/8 and turning it into its reduced version. What did I need to figure out in order to turn 6/8 into 3/4?
You need
What
to know,
value was I searching for? Go ahead.
you need to know the largest common denominator to divide by.
Okay, largest divisor, yeah. So I need to find the greatest common divisor of the numerator and the denominator. So find the largest value that evenly divides both the numerator and the denominator. All right, so in this case, we probably want to start at the smaller of those two values, right? Because the largest value that possibly will divide both of them evenly in this case would be 6. As a human being, we've glanced at it and know that's not the case, but we start at 6, then we go to 5, then we go to 4, then we go to 3, then we go to 2. We find that, oh, 2 does evenly divide 6, 2 does evenly divide 8. We have our answer. So in this case, 2 is the largest value. So 6 divided by 2 gives us 4, or I'm sorry, gives us 3. 8 divided by 2 gives us 4. So we have 3/4 is our answer. So for our homework, create a method to add a fraction to another fraction. This method should be an instance method belonging to a fraction and should take another fraction as a parameter and returns a new fraction that is the sum of the two fractions. Two fractions being self and the fraction that was passed as a parameter. Okay, so a fraction knows how to add itself to another fraction. Similarly, create a method to add or to reduce a fraction to its, well, let's reduce its fraction in place. So if a fraction was 6/8, after we call reduce, passing it no parameters, it would now be 3/4. Okay, so it permanently change itself to its reduced form. All right, so for our homework, we're writing two methods. One allows a fraction, gives a fraction the ability to add itself to another fraction, producing a brand new fraction, which is the sum. The second one is the ability for a fraction to reduce itself to its lowest form. All right, questions about the homework assignment? All right, so I will update Blackboard with this information for this homework due on Wednesday. Questions, comments, concerns, bribes? There, I just took attendance. Taking a screenshot of all the people on. Okay, so I will see everybody on Wednesday. Again, I'm on Slack all the time. Happy to meet with you on Zoom if you want to go through something. If you need a Zoom meeting for your study group, let me know. Otherwise, I will see everybody on Wednesday.
Stay safe. Don't die.
Yep, stay inside.
Don't run out of toilet paper.
And I'll hang out for a few minutes in case anybody has any questions or something staying after.